Now we will travel much deeper into space, several hundred light years toward Orion's belt. On our journey, we get a sense of the astonishing distance to these stars. The Hyades star cluster is visible on our right. We pass Bellatrix, the nearest of Orion's bright stars. Next out, Betelgeuse slowly drifts across the scene. A myriad of faint stars continually glides past our field of view. We are now roughly 400 light years away from home. As we pick up speed, we pass by Rigel and Saiph. Finally, we reach the nearest stars of Orion's belt. We have traveled a distance of 5 million billion miles into space. We glance back in the direction of the solar system. It is located here. However, the sun could not be seen from this distance without a telescope. It is a humbling experience to think of our entire solar system reduced to an invisible point. The constellations are completely unrecognizable from this distance. Although many of the same stars are visible, they no longer connect in a way that makes sense. Since we define the constellations as seen from our solar system, they point the way home. And as we travel back to the sun, they return to their familiar shapes. We now know that our sun is not the only system with planets. Astronomers have detected one or more planets around each one of the indicated stars. Several hundred extrasolar planets are now known to exist, and it seems likely that countless more remain undetected in the depths of space. In most cases, the planet itself cannot be seen directly. It is lost in the powerful glare of its host star. However, astronomers are able to measure the slight wobble the planet gravitationally induces on its star. This technique allows us to estimate the orbital period and minimum mass of the planet. In some rare cases, the planet passes directly in front of its star, as seen from Earth. The star V376 Pegasi has a planet that crosses its disk precisely every 3.52 days. Astronomers can measure the drop in the star's brightness and determine the size of the planet. Of course, this technique is only possible for the handful of star systems that are nearly edge-on relative to us. This planet is larger than Jupiter, but it orbits 20 times closer to its star than Earth orbits the Sun. This so-called hot Jupiter is a serious problem for secular models of planet formation. These scenarios had predicted that gas giants can only form far away from their parent star. Yet the vast majority of extrasolar planets so far detected are hot Jupiters. It's a difficult problem for secular notions, but not for biblical creation. Such diversity is what we would expect from the biblical God. This is the Upsilon Andromedae system. It has 3 known planets. All 3 are larger than Jupiter and orbit remarkably close to their star. The innermost planet is estimated to be 20 times larger than Earth in diameter. Its proximity to the star makes its temperature over 1100 degrees Celsius. Since current technology is not able to observe these worlds directly, we can only speculate what they look like. But we can be certain that their richness declares the majesty of their maker. In addition to stars and planets, the universe contains nebulae. A nebula is a cloud of hydrogen and helium gas spread over a vast region of space. Many nebulae are very hot and give off light. They are some of the most colorful objects in the cosmos. Some nebulae are relatively small, produced by the ejected gas of a single star. These are called planetary nebulae because many of them are round and appear like an out-of-focus planet. Planetary nebulae are quite common. Other nebulae are much larger, spanning many light years. These amazing creations can rightly be called the artwork of God. Our summer evening sky contains a number of other objects called globular clusters. They're too faint to be detected with the unaided eye, but are easily seen in binoculars or a small telescope. The globular cluster M4 is found just to the right of the red star Antares. Through binoculars, M4 appears as a faint, fuzzy blur. However, a telescope reveals that this blur is the combined light of thousands of stars. This is the most distant object we've visited so far. M4 is 7,000 light years away from Earth. That's 40 million billion miles. This globular cluster contains roughly 100,000 stars, yet it is only 50 light years across. This incredibly dense star field would be a wonderful sight. In addition to these countless stars, M4 also contains a strange object called a pulsar. It is thought to be the crushed core of an exploded star. Powerful beams of radiation emanate from the star's magnetic poles. When a beam sweeps past our field of view, we perceive a bright flash. However, if our solar system were not in the path of the radiation beams, we would not detect these pulses. By measuring the precise timing of these pulses, astronomers have learned that this pulsar is orbited by a planet. As with all extrasolar planets, we can only guess how this planet may appear. The view from this world must be absolutely breathtaking. On the other hand, it would be difficult to see beyond this bright star field. If we lived in a globular star cluster, we might never know about the vast universe beyond. M4 is merely one of more than 100 globular clusters that belong to our galaxy. This is our galaxy, the Milky Way. It spans 80,000 light years across and contains more than 100 billion stars. The Milky Way is a spiral galaxy. The brighter stars are concentrated into arms that wrap around the disk. Since our solar system is within this disk, we see the Milky Way as a cloudy band in our night sky. No human being or spacecraft has seen our galaxy from the outside, as shown here. It is difficult to grasp just how large our galaxy is. Our solar system is located here. In fact, with the exception of M4, all the stars and planets we've visited are within this little ring. The Milky Way is a remarkable demonstration of God's power. But what's even more amazing is that our galaxy is merely one of billions. Every one of these faint clouds is an entire galaxy.